So this question is coming from October number 20, paper 3, variant 2, and we are solving B part of this question. We are given a function and we are supposed to find the exact value of the integration of this function from 0 to 2. Now, whenever we are dealing with a fraction, we know that we are having integration roadmap for the division, and clearly it's not the f dash x over f of x format because the derivative of the bottom is not on the top. The first thing, a square plus bx square, is also not present over here because in the numerator also there is no constant. So we are going to think about the third rule, that is if we can express the given fraction into its simple format using the partial fraction or long division, that is the quotient remainder format. So clearly I can think of a partial fraction format. This can be expressed as a by 3x plus 2 plus bx plus c over x square plus 4. Now the first part of this question was to convert this into a partial fraction, but I deliberately removed it just so that you can think about it completely by yourself. You don't require part A for this kind of things. But yeah, in part A, it's just going to act like a hint for you for part B. And eventually you will be finding the value of A as 3, C as 3, and B as -1. So yeah, I'll let you try this completely by yourself. And then you will be finding the exact value of integrating this from 0 to 2. So I can say that therefore, or let us not start with therefore, I can say that integration from 0 to 2 of f of x with respect to dx is going to become integration of 3 over 3x plus 2 dx and then plus 3 minus x over x square plus 4 dx. And then this is from 0 to 2, this is from 0 to 2. Now, if you're able to solve this, then of course you will be able to get to the answer. Let us think about this. So if I integrate this, it is in the format of f dash x over f of x. If I take the derivative of the bottom, it is going to become 3, and 3 is already present on the top. So this is ln of modulus of 3x plus 2, and the limits are from 0 to 2. What about this? Is it f dash x over f of x format? No. Is it? What if I break this fraction further into 3 over x square plus 4 and then minus x over x square plus 4? I am sure we can do this so that it becomes a bit easier for us to think, because there is no other rule. Oops, let me just keep it back just a second. So yeah, there is no other rule over here. As you can see, neither the f dash x over f of x follows, neither the a square plus bx the whole square follows, neither the simple way of converting this fraction follows, because we already done that previously. So what else can we do? We can try to break this into two different parts. It is integration of 3 over x square plus 2 square dx from 0 to 2, and then minus integration of x over x square plus 4 dx from 0 to 2. And now I can carry forward ln of 3x plus 2 from 0 to 2. Then integration of this can be done with the help of tan inverse of rule. You are having a constant, and in the bottom you are having x square plus b square format, ax square, and a square plus bx the whole square format. The value of b is 1, a is 2. The answer will be 3 is a common factor that I can take out. So 3 over a into b, that is 2, times tan inverse of bx over a. B was 1, a was 2. And this over here, I think we can use f dash x over f of x rule, because the derivative of the bottom is 2x. I can just have a 2 over here to fulfill that, but I can't just have it randomly, so I'll also need to divide it by 2, so that this 2 and 2 nullifies. So this integration will become minus half ln of x square plus 4. And now what I can do is I can just remove this, and I can apply the limits everywhere from 0 to 2. So let us start. Do we need to find the simplified version? No. But being a student and you are practicing it, I always recommend that you convert it into the simplified format, even if it's not asked. So if I put 2 over here, it will become 6. 6 plus 2 is 8. So ln of 8, then tan inverse of 1 is pi by 4. So this will become 3 by 2 times pi by 4, just to be cautious. let me go ahead and do this. Tan inverse of 2 by 2, yeah, pi by 4, and then minus half ln 4 plus 4 is 8. This is minus half and ln 8. And yeah, now I can do the other part. I can just say that this is my first bracket minus the second bracket. If I put 0, I'll be getting ln 2. Then tan inverse of 0, of course, is going to be 0. So you don't need to write anything over here. Then minus half ln 4. Now you can simplify this as much as possible. So this will become ln 8 minus half ln 8. That is same as writing half ln 8, because ln 8 is a common factor and you are doing 1 minus half. So 1 minus half is nothing but half. So that is half ln 8. Then plus 3 pi by 8. Then over here I can write my ln 4 as ln of 2 square, and then I can bring 2 down. So it will become ln 2 minus ln 2, because the 2 on the bottom came down and got cut with this half. So I am having ln 2 minus half ln 4 as 0 only. So this has gone to 0. So finally I'm left with, yeah, this is my final answer. Half ln 8 plus 3 pi by 8. And you need to conclude that the integration of the function from 0 to 2 is coming out as this. Let us use our CAIE to cross check this. We had 7x plus 18 divided by 3x plus 2 into x squared plus 4, and the limits 0 to 2. We are getting 2.2178. Let's see if it is same as what we have got. Half ln 8 plus 3 pi over 8. It is 2.2178. So yeah, we can say that both are exactly the same. So we have confirmed our answer is 100% correct. And that is how you solve this kind of question. The important part was to realize that we can convert this into the partial fraction. And then after converting it into the partial fraction, this was a bit tricky, I think, for students, that how we can integrate this. The idea was to simply distribute the denominator for each term, and then you can integrate it with respect to the division rules. Over here we used tan inverse. Over here we use f dash x over f of x cube.